Hello everyone, myself Prayag Patel, working as an assistant professor in IT ICT department of LG Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the sorting algorithms. We have many sorting algorithms, but out of this all, consider the selection sort algorithm for today's video lecture. So in today's video lecture, I will discuss about the selection sort algorithm and example of the selection sort. Now first understand how selection sort will work. Selection sort divide the array or list into two parts. First part consider as the sorted part or the left part, and second part consider the unsorted part at the right side. So list divided into two part, left part and right part. Left part consider as a sorted list and right part consider as a unsorted list. Now consider the next step. Initially the sorted part consider as an empty list because all the element consider as an unsorted, so sorted part consider as an empty list. The smallest element is selected from the unsorted array and swapped with the leftmost element, and that element become a part of the sorted array. So in unsorted list, select the smallest element and swap with the first element. Then it finds the second smallest element and exchange it with the element in the second leftmost position. So this process continue until the entire list will be sorted. So this is called the selection sort process. So main step of this process is the smallest element is selected from the unsorted list and swap this element with the leftmost element. This is called the selection sort algorithm. Sort the following element in ascending order using the selection sort method. So for understanding the selection sort, consider this example and arrange this data in ascending order using the selection sort. Now here given data is 5, 1, 12, minus 5, 16, 2, 12 and 14. Now consider the step number 1. In step number 1, initially consider the given array as an unsorted array. Initially all the element considered as a unsorted. Here consider the location for this array as a 1, 2, 3, 4, 5, 6, 7 and 8. Now consider the step number 2. In step number 2, consider the first element as a sorted element. Here consider initially location number 1 consider as a 5 element, and this element initially consider I equal to 1 location 1 and value of the of I equal to 5. So that then we consider find the smallest value from the entire unsorted list. So here location 1 consider as a initial position. Now from the location 2 to 8 unsorted array consider the element 2 to 8. So from the unsorted array 2 to 8 find the smallest element. So find the smallest value from the entire unsorted array, means from the array 2 to 8. Now consider the smallest element from the location 2 to 8. Consider as a minus 5 as a smallest element and location consider as a 4. So minimum value or minimum variable store the location of the smallest value, and a of the minimum consider the smallest element value. So here consider the value as a of minimum equal to minus 5 and location consider as a 4. Now after that consider the first minimum initially value equal to location 1 and value 5. Then after we find the smallest element from the remaining list and smallest element consider as a minus 5. So we want to swap these two elements, means location 1 and 4 swap, means value 5 and minus 5 will be swapped. So here consider minus 5 at first position and 5 at the fourth position. So after the step number 2, your answer is like minus 5 at first position, then 1, 12, 5, 16, 2, 12 and 14. Now consider the next step, step number 3. In step number 3, initially we consider the array as a after the answer of the step number 2. So here minus 5 is sorted element. Now consider the next location, because in second step we perform the operation and put the values minus 5 at your desired location, means at location number 1, your proper place of the minus 5. Now consider the next location and consider the location number 2 as your location for this step. Now unsorted list consider from the element 3 to 8. So 3 to 8 element consider as a unsorted element. Now consider location 2 means I equal to 2, value of A of I equal to 1. Now find this minimum value from the remaining unsorted list, means here remaining unsorted list from 3 to 8. So find the smallest value from location 3 to 8 and consider the minimum value as a location 2 and value of the A of minimum equal to 1, because in unsorted list there are considered the all the element but minimum value at location 2. So no need to swapping operation. Here consider the value 1 at location 2 is proper, so did not require any swapping operation. So no swapping as minimum value is already at right position. Now consider the 1 as a sorted element because for the process for the value 1 is done. Now consider the next step, step number 4. In step number 4, first two value are already sorted. Now consider the next value, means consider I equal to 3 and value of A of I equal to 12. So third location and value 12 is initially considered. Now consider the unsorted array or find the smallest element from the remaining array. So consider the find minimum value from remaining unsorted array and minimum value consider as a 6 and value of the location 6 consider as a 2. So minimum equal to 6 and A of minimum equal to 2. So this location consider as a value 2 as a minimum value from the unsorted list. Now swap the unsorted list minimum value with your initial value at location 3. So consider the 12 and 2 value means location 3 and 6. Swap these two element location 3 and 6. Now consider the swapping operation. So put the value 2 at location 3 and put the value 12 at location 6. Now after that consider the next step, step number 5. In step number 5 already first 3 elements are sorted. Now consider the location number 4 as initial value and remaining location from location 5 to 8 consider as a unsorted array. So here I equal to 4 and A of I equal to 5. Now find the value or minimum value from the remaining unsorted list. Here consider the smallest value at location 4 and value consider as a 5. So this is at a proper place. So no swapping operation is required because minimum value is already at the right place. Now consider the next step, step number 6. In step number 6, consider the first 4 value as a sorted list. Now consider the location number 5 as initial point and remaining list consider as a unsorted list. So here consider the I equal to 5 as your initial position and value of A of I equal to 16. Now find the smallest value from the remaining list or remaining unsorted list. So minimum equal to value 12 and location equal to 6. So here consider minimum equal to 6 and A of minimum equal to 12. So here consider the swapping operation between location 5 and 6. Value 16 and 12 will be swapped. So after swapping, consider the value 12 at location 5 and consider the value 16 at location 6. Now consider the next step, step number 7. In step number 7, first 5 value are already sorted. Now consider the location 6 as an initial value, means I equal to 6 and A of I equal to 16. Now unsorted list consider as a last 2 element location 7 and 8. Now find the smallest value or minimum value from the remaining unsorted list and this is considered as a location 7 and value of the location 7 equal to 12. So 12 value consider as a minimum. So swap the 12 with the 16 because 12 is minimum then 16. So swap the 12 and 16. So put the 12 at location 6 and put the 16 at location 7. Now after that consider the next step as a step number 8. In step number 8 only last 2 elements are remaining for sorting. So consider the location 7 as your current location and remaining location 8 consider as your unsorted list. So here consider the I equal to 7, A of I equal to 16. Now consider the find the minimum value from the right side portion or unsorted list. So find the minimum value from remaining unsorted array, and this is considered as a minimum equal to 8 and value equal to 14. So 14 is minimum than 16. Then swap these two elements 14 and 16. So put the 14 at location 7 and put the 16 at location 8. So here consider the step number 8 as your final step. After the step number 8, your list will be sorted list or ascending order list. So using selection sort algorithm, you can arrange your data or given list into the ascending order like this. So here your answer is -5, 1, 2, 5, 12, 12, 14 and 16. So this list consider as a sorted list. Now consider the algorithm for the selection sort. Now here consider the algorithm: input array A, then output sorted array A. You require the output as a sorted array. Now name of the algorithm consider as a selection sort. In bracket we can write the A means argument consider as a array A. Now for I equal to 1 to n minus 1 2. Here consider the first for loop from 1 to n minus 1, because initially we start the process at location 1 and this process will be continue until the previous element of the last element, because here if we consider the previous element of the last element means n minus 1 element, then n minus 1 element will be compared with the last element. So this process or this loop for the how many number of passes required. So here n minus 1 passes required. So consider the outer loop for I equal to 1 to n minus 1 means n minus 1 steps or passes are required to sort the data. Now consider the in this loop first element or first argument is minimum equal to I. So initially I equal to 1. So initial location initially considered as a minimum value by default. So minimum equal to I. For j equal to I plus 1 to n means initially we consider first location as a I, then next location of I consider as a j. So j equal to I plus 1 to last location means up to the n. Do the following process. Here consider the process as a if a of j less than a of minimum. Here a of j means, for example, initially consider I equal to 1, then j equal to 2. So a of j means a of 2 less than a of minimum. Initially minimum equal to I, so a of 2 less than a of minimum, then minimum equal to j. So we can say that if the a of j is less than a of minimum, then consider the j value as a minimum value. So this is considered as a for loop or inner for loop. Now using the inner part of the for loop or inner for loop of the j, here consider j equal to I plus 1 to n and if condition and minimum equal to j. This process will be repeated and find the minimum value from the unsorted list. After finding the minimum or smallest value from the unsorted list, you will swap your answer or minimum value with the initial value of I. So here consider the next step as a swapping between I and minimum value or smallest value. So a of I value transfer into temp variable, then a of minimum transfer into a of I, then temp value transfer into a of minimum. So we can say that transfer or swapping between a of I and a of minimum. So this is considered as an algorithm for selection sort. Now consider the analysis part of the this algorithm. So here initially you consider one example how this algorithm will work. We understand using this example. So initially consider this array as a unsorted array. Now you want to sort this array into the ascending order using the selection sort algorithm. Now initially first condition is for I equal to 1 to n minus 1 2. So here consider pass number 1, step number 1. Initially I equal to 1. Now consider the I equal to 1 means you can say that I equal to 1 means minimum equal to 1. So here consider minimum equal to 1. Now next step is a of minimum. What is the value of a of minimum? A of 1, and a of 1 equal to 45 according to our this example. So here 45 as a of minimum. Now consider the next for loop for j equal to I plus 1 to n. So here I equal to 1. So initially consider value of j equal to 2. So from j equal to 2 to n you can perform this operation. So initially consider value as a 34. So consider this loop if a of j less than a of minimum, then minimum equal to j. Now consider the value of the minimum as a already we consider 45 as a minimum value. Now in this step consider the a of j as a minimum. So we can consider minimum value as a 2 and a of minimum equal to 34 because 34 is less than 45. Now consider the next value of j. Next value of j equal to 3. So consider the next value as a 56. Now check 56 is minimum or 34 is minimum. So 34 is already minimum. So no need to change any value. So consider 34 as it is as a of minimum and minimum location consider as a 2. Now no any change. Now consider the next value of j and next value of j equal to 4. So for the value 4 consider the minimum equal to 4 and a of minimum equal to 23. So 23 is less than 34. Yes, then we can say that here consider the next value of a of minimum equal to 23 and minimum equal to 4. Now consider the next location j equal to 5. So move to the last location and value of the a of 5 equal to 12. So consider this value is less than your previous minimum 23. So previous minimum value is 23 and new value equal to 12. So swap or change this value means here consider the 12 as a final value a of minimum and minimum equal to location 5. So this process will be executed for each and every bus. So here consider the 12 as a minimum value. Now swap the 12 with the your first value means 45. So after the swapping process you can put the 45 at last location and 12 at first location. So second step consider as a your first pass completion result means after the first pass you will get the answer like this. So in this case your 12 will be occupied its proper place. Now consider the unsorted list as a remaining 4 element. Now for this 4 element same process will be executed and swap the 23 and 34 and occupy the 23 is proper place. Now consider the next value as a 34. Now consider next value as a 45 and last value as a 56. So using selection sort algorithm you can arrange the data like this. So this is a selection sort algorithm. Now consider the analysis part of the selection sort algorithm. We already discussed this algorithm one by one step. You can consider this algorithm. Now how we can analyze this algorithm. So here consider first loop. I look from I equal to 1 to n, then minimum equal to I, then j equal to I plus 1 to n. Then consider the condition as a of j less than a of minimum, then minimum equal to j, then swapping operation between a of I and a of minimum. So this is your algorithm. Now consider the analysis part. What is the time complexity of selection sort algorithm? So here consider the first loop for I equal to 1 to n minus 1 means this loop will be executed for n time. So outer loop execution time equal to theta of n because this loop will be executed for n time. Now for the inner loop j equal to I plus 1 to n. How many times this loop will be executed? For one value of I you can execute inner loop for n time. For second value of I you can execute inner loop for n time. So that's why we can say that inner loop will be executed for n square time. So inner execution time equal to theta n square. So final complexity of the selection sort algorithm is theta n square. Now consider one by one step how you can find the complexity in proper way. So consider this algorithm and find the final complexity according to our method. So first consider one by one line of the algorithm. For each and every line you can consider the cost and time. Cost factor consider as a C1, C2, C3 like this, and time factor consider as a your how many time particular statement will be executed. So for I equal to 1 to n minus 1 outer for loop cost equal to C1, time equal to n because from 1 to n minus 1 total n minus 1 time your condition will be satisfied and 1 time for your wrong condition checking process. So consider the total time equal to n. For the second line consider minimum equal to I. So cost equal to C2. How many times this statement will be executed? N minus 1 time your loop will be satisfied. So time equal to n minus 1. Now consider the inner for loop for j equal to I plus 1 to n do In this for loop, you can consider the if condition. If a of j less than a of minimum, then consider the minimum equal to j. This three statement consider as a one common statement. You can consider individual also, but in this case we can consider this three statement as a approximately same process or same time. So that's why we can say that this three statement consider as a common statement and cost equal to C3. Now time required for this three statement consider as a sigma I plus 1 to n I, because here starting position from I plus 1 to ending process at end location, and how many times this statement will be executed, this is depend on the value of I. If we consider the value of I equal to 1, then consider this statement as a starting from 2 to n. If we consider I equal to 2, then this process will be executed from 3 to n, then 4 to n, then 5 to n, then 6 to n, like this. So this process is like sigma I equal to 1 to n I, like this. So we can consider the sequence like 1 plus 2 plus 3 plus 4 plus 5, like this. So this statement commonly written as sigma I plus 1 to n I. Now consider the next statement, swapping operation. Swapping operation is outside of the inner for loop. So this loop consider as a in your for loop of I. So here cost equal to C4 and time equal to n minus 1. Next statement C5, time equal to n minus 1. Next statement cost equal to C6 and time equal to n minus 1. So last three statement consider as an individual, as well as you can consider as a common complexity or common time and cost. So this is a individual cost and time for each and every line. Now how you can find the complexity from this sequence? So consider the cost into time for each and every line and addition of each and every line cost into time. So C1 into n plus C2 into n minus 1 plus C3 sigma I plus 1 to n I plus C4 n minus 1 plus C5 into n minus 1 plus C6 into n minus 1. So here consider this sequence. We already told that. Now solve this sequence or this equation T of n. So T of n equal to C1n plus C2n minus C2 plus C3n square by 2 plus C3n by 2 plus C4n minus C4 plus C5n minus C5 plus C6n minus C6. Now we can consider the n square factor, common factor of n square, then n, then constant factor. So here consider n square into C3 by 2 plus n into C1 plus C2 plus C3 by 2 plus C4 plus C5 plus C6, and constant part as a minus C2 minus C4 minus C6. So this statement will be written like this: an square plus bn plus c. So here consider the complexity as a big O of n square, because here highest power of n consider as a n square. So complexity consider as a n square. So time complexity of selection sort algorithm is considered as a n square. In today's video lecture, I will discuss about the selection sort algorithm and how you can find the complexity of the algorithm. Thank you for watching this video.